Why can you see your reflection in some objects? In this video, we will look at ray diagrams for reflection, refraction, and colour absorption. Visible light is part of the electromagnetic spectrum. Light is a transverse wave and travels in straight lines. When light hits an object, it can be reflected, refracted, or absorbed. Reflection is when light bounces off an object. The angle of incidence is equal to the angle of reflection. So if a ray of light hits an object at 45 degrees, it bounces off the object also at 45 degrees. Or hits at 30 degrees, then it would reflect also at 30 degrees. A rough surface, like wood or clothing, scatters the light so that it reflects in all directions. Smooth surfaces, like glass or polished metal, reflect the light in a regular way, so a reflection can be seen. When drawing ray diagrams, the angle of incidence is always equal to the angle of reflection. The angle of incidence is the angle between the normal and the incoming incident ray. In this question, can you work out the size of angles I, Q and R? Pause the video and work them out. Did you get the angle of incidence as 34 degrees? And the angle of reflection is also 34 degrees. And angle Q is 56 degrees. Can you label the different parts of this reflection ray diagram? Pause the video and give it a go. Did you get them correct? So what happens during refraction? Sound waves and light waves change speed when they pass across the boundary between two substances with different densities, such as air and glass. This causes them to change direction, which is called refraction. If a light wave passes from a medium in which it travels faster to a medium in which it travels slowly, then the light wave will bend towards the normal. Whereas, if it goes from a slower medium to a faster medium, the light wave refracts away from the normal. Just like with reflection, refraction also has an angle of incidence and then has an angle of refraction. In refraction, the two angles do not equal one another because they are travelling through different medium. The greater the change in speed, the greater the angle of refraction. There is one special case you need to know. Refraction doesn't happen if the waves cross the boundary at exactly 90 degrees. If this happens, they carry straight on. Because of refraction, water looks shallower than it really is. And a straw in a glass of water looks like it bends at the surface. The light ray refracts as it leaves the water, making the straw appear bent. So there we've seen reflection and refraction and the associated ray diagrams. Both have an angle of incidence, and then there is an angle of reflection or refraction.